Good afternoon, everyone. So, today we'll be going to discuss the same chapter that we have discussed in the last class, that is the civil engineering works for metro system and engineering. In the last class, we have discussed the viaduct thing that is used for the that is adopted for the elevated kind of metro stations and metro system, the basics of the viaduct, the construction of the viaduct, all these things we have discussed in the last class, how the PRC fire formation system is used for the viaduct construction. That thing we have also discussed. Then we have discussed in a detailed way about the three kinds of metro stations which are used in case of metro system and engineering. This is the first one, elevated station, untracked stations, and underground stations. These things we have completed up to the previous class. Now coming to the rest part of the metro station and metro building construction. Now here the first thing we are going to discuss here is the dimension of the metro stations, and there are some general provision for the dimension of the metro station, like provision for the length of the station is in order of 75 meter to 90 meter, but obviously you know that the provisions are given from the statistics and the previous experiences. These are the empirical kind of things, and obviously in some cases when required these ranges of 75 meter to 90 meter, these kind of ranges may be omitted and may be avoided, and some other amount of length or other amount of values we may use. So, but the provision, general provision for the length of the metro station is 75 meter to 90 meter. The width of the metro station, this is also a general provision, varies from the 24 meter to 30 meter depending on the local condition, like road width, peak and drop facilities, etc. That means if road width is greater and peak and drop facilities will be provided with the metro station, then the higher ranges of width should be adopted. It is desirable to have parking facilities at least for two-wheelers. That means in the metro cities, obviously we know that in the metro cities, the metro rail that mode of transportation of metro system is adopted. So in that case, if the parking is not there, parking facility is not there, that is of no relevance. So at least for two-wheelers, for parking is facilities should be there, but desirable is that full four-wheeler parking facilities should be there. So this is the part of the construction for the metro station, the provisions for the construction of metro stations. Now the techniques of the construction of the metro station. Now here you can see there are two parts. This is general for all of the structures in the civil engineering purpose. There are two parts, one is the foundation and the superstructure. So you can see there are two separate headings. One is the construction of foundation for the metro station and another is the construction of the superstructure of the metro station. Now here for construction of the metro station, if you can remember in the last class we have discussed about the pier foundation which are used for the construction of viaduct, that means the elevated kind of metro system and metro station. But in case of station buildings, we have to go for the pipe foundation. Generally, pile foundations are adopted for the construction of station buildings. Otherwise, mat or raft kind of foundation may be possible if underlying there is a condition. Underlying soil has adequate self-bearing capacity. That means if the underlying soil strata is strong enough to bear the load or to afford the load from the superstructure, then we can go for mat or raft foundation. Now these two kinds of foundation, I think in the foundation engineering you have studied, and in the previous semester you have two site visits, both for one is for the mat or raft foundation with the footing, that is the shallow foundation, and another site visit we have conducted for the pile construction. So I think all of you have the clear idea about the pile foundation and mat or raft foundation. So this is the provision for the foundation under the metro station when there is construction for the construction of the station buildings, and next is for the construction of the superstructure. Now for the superstructure after the pile foundation, we have to go for the pile foundation. That means pile foundation, you know, there are good action of pile foundation. So some pile foundation taking a number of pile foundation, after that pile cap, after that pile foundation is constructed, and a single pile carries the entire superstructure load including the track load of the metro rail. So this is the superstructure is included starting from the pile foundation. Now piles are uniformly placed at closer intervals about 15.5 meters center to center distance compared to the spacing of viaduct piles. That means when we have discussed about the viaduct or the elevated kind of thing, there the spacing of the pile is much higher, because what is the reason? The reason is that the availability, the space availability is very much required in case of elevated kind of metro station or elevated kind of metro system. That's why in that case the not more closer intervals are given, but in case of station buildings closer intervals are given. Provision is up to 15.5 meters center to center distance should be given under the station buildings. There are extended fire arms both at the concourse level and platform levels. If you can remember, there are three levels for the elevated kind of metro system or metro station. One is the first level, that is the ground level, that is the entry level. Second one is the first level, that is the concourse level, and third one is the second level, that is the platform level. So for the platform level and for the concourse level, extended arms like this, extended arms of the pile foundation should be provided so that these arms can hold the width of the platform and width of the concourse level. For supporting the concourse load, precast RCC beams are adopted. They run longitudinally and rest on the extended pile arms, and thus transfer superimposed load to the pile. For the concourse level load, the concourse level obviously in the perspective of loading, the superstructural load, one of the part of the superstructure load is coming from the concourse level superstructure. So this for this superstructure load, precast RCC beam. That means RCC beam which are already precast in the and fabricated in the plant and taken to the side. This kind of precast RCC beams are adopted longitudinally. They have been placed and rest on the extended arm of the fire arms that I have told you these kind of firearms are provided that transfer the superimposed load to the fire. Now precast technology fast beams and girders are suitable. That means in the previous class also we have discussed that I have told you that precast kind of things, precast kind of slab, precast kind of beams are always very much suitable of the metro system construction. So precast beam, precast beam, precast slab kind of things are very much suitable for metro system construction. Now track structures for the metro system. I think all of you know what is track. In the railway also you can see the tracks. Tracks means the rails and that longitudinal rail and lateral thing and some stone chips were there. These things are that stone chips. Those stone chips are not the regular stone chips. Those are ballast. Okay. Depending on the presence or the adopting of the ballast thing in the track, we can have two kinds of track, and another is the embedded track. So three kinds of metro railway track is adopted in the different conditions. Those are ballasted track, second is the ballast-based track, and third one is the embedded track. Now ballasted track is simply you can remember by the way, ballasted track means where the ballast means the large stone chips. You can see those in the railway tracks also, the stone chips. Okay, large stone chip kind of thing, those ballast. If those ballasts are used or adopted in between the tracks, then that is ballasted track. If ballasts are not provided in between the tracks, those are ballast-based track. Third one I will be discussing later. Now the normal ballasted track which is suitable for the added portion of the main line. Added means where two levels are there. Only entry level and concourse level is the same level, and another one is the platform level. So platform level is the second level after the ground level. So added portion of the main line ballasted tracks are suitable. That means ballasts are provided. This kind of track has a resilient track bed with cushioning characteristics. Cushioning characteristics means elasticity. Elastic thin cushioning characteristics are coming from the presence of the ballast. So if the ballasts are present in between the tracks, then resilient track bed characteristics with cushioning characteristics are there in this kind of ballasted tracks. Which the advantage is that reduces the transmission of vibration. Though the track needs more maintenance, cost is lower. The advantages and disadvantages we will be discussing later. Now, due to this cushioning characteristics, the vibration is reduced. This is one of the advantage, but disadvantage is more maintenance and cost, that is economy of the cost of this kind of track construction is higher. Now coming to the ballast-based track. Ballast-based track, that means where the ballasts are not provided in between the tracks. Simple. Now ballast-based tracks which is recommended for the viaducts and tunnels. That means other two kinds of metro system. One is the added, another is the elevated, another one is the underground. So for the added stations or added system of metro system, ballasted tracks are suitable. For viaducts and tunnels, that means for the elevated metro system and the underground metro system, ballasted tracks are suitable. These kind of tracks have a reduced dead load. Why? Because their ballasts are not present there. The load of the ballast are not present there. That's why dead load is lesser as the dead load of the ballast is reduced. Now these are nuisance free and maintenance free track structure. As the ballast are not there, that means dust, the friction between the wheel of the metro and the ballast will produce the dust. As the ballast are not present there, that means the dust are also not there, and that means the maintenance. These are the low cost and low maintenance track structure. And embedded tracks are recommended in the workshops and the bus plant lines. That means these are not for the main metro stations or metro systems. These are used for, these embedded tracks are used for workshops and bus plant. That means plants. Where the repairing works or washing things are taken care. Those things in their embedded kind of track structures are used. Okay, so this is the thing we have discussed today, that is the provision for the dimension of the metro stations. General provisions are given. Next, the construction of the station building, the technique and the provisions for the constructions of the station building for the metro system, those are discussed. And the track structures for the metro system, those we have discussed. So this is the thing. We are stopping here and for the discussion of the metro system class, but we will be continuing the campus preparedness thing after this.